Hey. Yeah, so hi everyone. Glad to be here. So my name is Ansgar, and I'm with the Quill team. We are like a collaboration between Consensus and the Ethereum Foundation, and we basically help the Ethereum Foundation with all things core development, so research and analysis, implementation, testing, tooling, specification, all these kind of things. And I'm going to talk a little bit about the base layer roadmap, but just given that it's only 20 minutes, I thought I picked the most interesting area within that, and that's the scaling roadmap. So I'm going to talk about scaling for a bit. So let's see. I'm going to start a little bit with the history and then kind of work my way to the current situation in the current day. So as most of you probably are aware of, from the very beginning, there were some scaling plans on the Ethereum roadmap, and the kind of the core insight that still holds true today. And I think Preston talked about it at the very first talk of the day. So if you've been around since then, you might have heard about that already. But like the idea is pretty simple. Like you can't just scale a monolithic blockchain by just pumping more and more transactions through the same pipe, basically, just because like fundamentally it doesn't scale to have every user validate every interaction of every other user, right? Like you can't scale that to billions of human beings. And so the very first naive idea that we had on Ethereum was just, let's just take the EVM, copy paste it, basically have 1,000 separate chains, and then just sprinkle some sort of interoperability on top. And that's kind of what we call charts and charting, and that's where this kind of idea started. Then this is more of a little bit like an archaeology lesson. That was kind of like just all the branches we went down through. So some of you might still remember names like eWasm. That was basically the idea. Well, if we're already spinning up new chains, we might as well not just copy paste the EVM, but do something better, right? If we start from scratch, why not do something like this? eWasm stands for Ethereum Web Assembly. So the idea was get rid of the EVM, do something better. Then we had execution environments. That's actually when I became a co-developer like 2.5 years ago. That was like the hot topic back then. So the idea is we want to really give projects the utmost freedom. So we want to basically give them the ability to design their own chains. So instead of writing smart contracts in WebAssembly directly, what if you could just write a virtual machine in WebAssembly called execution environment, and then inside the virtual machine you can just run things the way you want to run them. It turns out like that was just one abstraction layer too much. So we really wanted to have shared security across shards. It doesn't really like mean anything to have the same Ethereum system if you don't get the full security on each shard. And for that, you need like rapid validator rotation. And then we figured out, well, you need to be able to sync very rapidly as a validator if you want to switch every few minutes. So you can't really have the states, the shards have state that someone has to manually download. So all the shards would have to be stateless, but stateless execution is really computationally intensive. And so at some point, we just ran into performance limits. And so at the same time, though, like all these ideas around execution environments actually kind of progressed into what we nowadays call rollups, right? So basically, over time, people just realized this is the wrong approach, but there is something in the layer 2 space that basically gets us the same result, just in a smarter way. And so from the base layer perspective, though, that meant that we went all the way back to a simpler version. And like, what exactly is rollup in this context? Well, I mean, rollups, for one, they basically the result, the combination of many years of layer 2 research. So I think the very first Bitcoin paper on hash lock payment channels was all the way back in 2014 or something. Then we had Plasma that we spent a couple of years on. And then finally people basically came up with rollups. And the key idea here basically is that you gain a lot by separating data and execution. And data in this context just means all the transaction data. So like basically all the activity that happens on a rollup. And if you basically just consider that as like just raw data for a second, and then actually running them as a separate action, then basically thinking about it in that separation, you start to realize that there's basically different things that the base layer has to do. Because for data, it's really important that the base layer actually basically has a look and double checks that it's available. That's kind of this data availability that you probably might have heard about. So that's a service that's really crucial. But that's a very specialized service just for data. And then the execution, we found more and more clever ways of basically compressing that down. And nowadays, we have these two approaches with ZK rollups and optimistic rollups, where basically we compress that all the way down to validity proofs and fraud proofs. And those are much more efficient than actually naively, as we did with execution environments, running all of it on the base chain. And so doing the separation, now basically we realize that we really have to, because we already have all the tools for the validity proofs, the fraud proofs we can already do with the EVM. So what we really have to focus on is scaling data. So now the problem for Ethereum scaling boils down all the way to scaling data. And with that in mind, basically the sharding design went through several iterations. So after we kind of gave up on the whole EWASM approach, we kind of were already back at like pure shards, because we realized like people that don't want all these many shards, they want fewer shards with like more tighter interoperability. But then actually with the whole rollup vision, it became more and more clear. You don't really, like rollups only need data. So we only need a couple execution shards maybe, and then mostly just data. But if you think that all the way through to the logical end, and each of these steps took months to kind of, it makes it all look very simple now, but so you really kind of only need one execution shard, and while we're at it, we can just use ETH1, right? Until like 2 years ago, the plan was actually to have ETH1 just remain separate, maybe have a bridge at some point, but ETH2 was supposed to be this entire new thing. Some people don't even remember that anymore, but now, of course, it's obvious that we have the merge and everything will be one system. But it's just because we happen to only need one execution shard, we already had one, so like, why not just pick it? And then this is the last point here is actually the one, the most recent one, the most exciting one, and that's basically, well, not the most, one of the currently very exciting ones, and that's just, so there's a researcher in the Ethereum Foundation called Dankrad Feist, and he basically came up with it, so that's why it's now called Dank sharding. And basically the idea is, if we only need the shards for data, why do we even need shards at all, right? We really like, there are much more efficient ways of scaling data where you can have more complex sampling algorithms and everything. We don't need this sharding structure anymore. So we basically got rid of sharding completely. Unfortunately, the name sticks. So we probably will call it sharding until the end of times, although I would really like us to just no longer call it sharding. But it's the same throughput in data. It's just in a more clever form now. And I'll talk a little bit more about that in a second. But like, I think what people always are a little bit vague about is like, why do we need data? What does data even mean in the context of Ethereum? Sure, everyone always says rollups need data, but what does that mean? So basically the only form of data, so there's a little bit of a data deep dive. So the only form of data we have today on Ethereum is call data. So that's when you send a transaction, there's always like this, if you basically look at what the transaction under the hood looks like, there's always like a data field where you can just put an arbitrary payload, just some bytes. And usually, like how Solidity uses that is just for the function selector, like what function do you want to call, what parameters do you send with the call, these kind of things. But that's the only way of actually putting data onto the Ethereum chain today. And the problem is that this form of data is really expensive. So one of the two reasons for that is that nodes currently store the data forever. So like you can still go and look like a transaction sent 5 years ago, what data did it have? And your Geth client will return that information to you, right? It still stores that to this day on disk. That, of course, doesn't really scale, but it is required for full sync and querying the history. We will, however, start breaking this invariant. So with EIP 4444, if you have never heard of that, probably worth a look. We'll start limiting historical storage to 1 year. So that will give us a little bit of more headroom to make data a little bit cheaper. Importantly, though, there's another bottleneck, and that's a much more fundamental one, and that is, it's almost trivial, but like if every node has to store data forever, of course, every node has, in the first place, to download the data. And that's basically very similar to this whole sharding problem in the first place, right? Everyone validates everyone else's things. Like, it just doesn't scale if I have to download everyone's data. That just fundamentally doesn't work, right? But with call data, that has to be the case, because with call data, that is passed into the EVM, so you can't execute the transactions without it. So you can't validate a block if you don't have all the data. So there's no way around downloading all of it. So this is really the fundamental bottleneck that we had to kind of solve. And the way we did it was by just introducing a new type of data. So this will forever be basically expensive and limited. So now we have a new type of data, or we will have a new type of data. And that's, well, we don't have a name. Sharded data. We should not call it sharded data. It's not sharded. There's nothing sharded about it. But that's, for now, what basically people call it. In order to understand why that's useful, so just looking at rollups for a second. So the only thing that rollups really do on the base chain is management. So what does management mean? Well, rollups basically are just sidechains. So like, I don't know, XDAI, Gnosis Chain, like Polygon, all these things, just with a twist, right? Sidechains also always keep track of the state, right? And they basically checkpoint to the base chain. But what sidechains also do is that they have their own security models. Rollups, on the other hand, inherit the security from the base chain, and they do this by running these ZK or fraud proofs. Importantly, though, during this entire management process, you only ever use these cryptographic pointers to the data, like hashes or these kind of things. Rollups never actually need the data. They can't they? They all shove it into the call data, but then they never look at it. They just put it on there, again, for this data availability. So they basically, that the base chain can give them the stamp of approval. This data was available. You didn't hide it in a corner. It was actually out in the open for everyone to see. But then they don't actually need to use it. They only need this cryptographic pointer to it. And this is basically where now we can make things more efficient. Because now we introduce this new type of data, and I felt like it was too much of a technical deep dive to really look at how that works under the hood. So I'll only give you the properties of what that looks like. But this new type of data still guarantees the same availability, so there's no compromises on the security front. But it only passes the pointers into the EVM, right? Rollups only need that. And crucially, nodes will only download small portions of that data, right? This is, maybe you've heard of the sampling and everything. That's where the efficiency gain comes from, right? You only look at, you as a normal node, you only download a super small subset of that data, and so we can have much more of that. And then, importantly, also, you only store the data for a small amount of time. That's an additional efficiency gain, but that's the less important one. I think in running through this in advance, I realized that these two slides are a bit too much of a deep dive, and I don't have time for them. But if you want to find the slides afterwards and maybe look at what exactly this looks like for ZK rollups and for optimistic rollups, be my guest. But it's really just a quick aside. So what's kind of the timeline here? When do we get all the scalability? When can we start really fully moving to the layer 2 world? Quick disclaimer, people always lynch core developers for giving timelines because we never keep them. And so this is, that's why I importantly always put this net. This is just no earlier than, right? It could come 20 years later. This is not a promise. This is just like a, basically, if everything went as smoothly as humanly possible, right? So the merge, importantly, does not have a net, because the merge, we are reasonably confident we can do this summer. There can always be hiccups and whatever. So this is not guaranteed, but this is like likely, really likely that we'll do the merge this summer. And the merge itself, importantly, this is a takeaway if you weren't aware, the merge itself does not scale Ethereum, not a little bit. There's no scaling in the merge. It is a preparatory step. We have all these other nice side benefits, no proof of work, all these things, more security, but it does not scale Ethereum. It just prepares Ethereum for being scaled. But then the next fork after that, that's called Shanghai, at the very earliest, towards the end of the year, there we are aiming at introducing this thing called mini dank sharding. So this is kind of dank sharding, just in a slightly cheated way. So we don't actually do this whole data sampling when everyone only downloads a fraction. We still have everyone download the full data, so we can only have a little bit of it, otherwise it would blow up in size. But at least from inside the EVM, it already looks like this new type. So you have all these cryptographic pointers and everything. Everything is basically just as it will be in this beautiful final world that we'll end up with. And so rollups can already start using this and transitioning the systems towards this. So once the full sharding comes around, at the very earliest, optimistically say end of next year or something, that's just when we basically actually teach the nodes how to do this sampling and whatever. And that time, from inside the EVM, everything looks the same, just the throughput goes up by a factor of literally 100 or something. So at that point, basically, all of a sudden, rollup data becomes really, really, really cheap, and using rollups will be in this magical world where like a transaction is a cent or so. That's, or maybe even less. So that's basically what we're aiming for. And let me maybe just, towards the end, just briefly like look at what does this mean for, oh, nice, maybe I even have time for, I'm quicker than in my practice, nice. So, sorry for being maybe a bit fast then. But so what does it mean? Like, where does this leave Ethereum? What's kind of the TLDR here? So if you follow people like, I don't know, Polinia on Twitter, these kind of people, you might have heard this term thrown around, modular blockchain. I think that's a really nice way of kind of putting it. So the idea is basically, we're kind of starting to understand now that the best thing to do in sharding is we try to provide the bare minimum that's necessary for sharding on the base layer. So we only basically provide data. And then everything on top of that, we leave completely open for layer 2 projects, for rollups, to basically make their own choices. And the nice thing is that this opens this huge design space for them to experiment with whatever approach they want. And you know, right? There are like already a dozen different rollup projects, and there will be more in the future, I guarantee. And that means we can have ZK projects, we can have optimistic projects, we can have hybrid projects. I haven't seen any of these yet, but that'd be really exciting. We can have on-chain data, off-chain data, hybrid data, compression. We can have trade-offs in terms of, do users like rollups that are a little bit maybe less throughput but have super high security, or maybe some others where like it is more expensive. You need like more expensive computers to fully validate the chain, but maybe some users don't care. Like we don't want to have an opinion, right? Like everything can just be tried out in parallel, and then whatever users adopt, right? So basically, we just give you the building blocks, and then you can build anything on top of that you want. We can have experimentations with parallelization, which I'm also really excited about. We can see, does the EVM make sense as the best thing ever, or like will we at some point have better VMs? I think that's very feasible. Same with Solidity. Maybe other languages will at some point take the spot. And also things like general purpose rollups, app-specific rollups. All of this is basically completely open, and we're basically, with this, we're bringing all the diversity that we have in the layer 1 space into the layer 2, but importantly, and this is the main difference, in layer 1, every time you have a new shiny new base layer with new features, you basically compromise on security, because then you have to trust that specific trust model of that chain, and it's the total trust of the network is split between all these different layer 1s. With layer 2s, all of them inherit the security of the base chain. So all layer 2s have the full security of the Ethereum network, but whatever features they want, right? This is exactly why we're building this, basically. And then as a last slide, this is the laser pointer. It's like a question that I think we're only starting to actually see come up, and where I don't want to present an answer, just kind of leave you with a question, and maybe, I don't know, if you want to find me after and have thumbs up on this, that would be interesting to discuss. And that's, so basically, Ethereum in the beginning was a highly bundled project, right? There were no other smart contract platforms around, so you had to basically bundle everything into one package, like the consensus, the money, the data, everything, like what was basically the execution, right? The clients, the programming language, everything was one big bundle. And now we're starting to unbundle and only keep things together that really make sense on a base layer. But what that means is that some of these building blocks that we put a lot of effort into designing now aren't actually in the responsibility of the base layer anymore. And the most important thing, I think, is actually the UX. Like, we put a lot of effort into designing the EVM so that it's easy for users to use. We have Solidity, we have the clients, we have tooling, we have all of these like libraries. We put a lot of effort into what does it look like to build dApps on top of Ethereum. But in the future, people won't build dApps on top of Ethereum. People will build dApps on top of Arbitrum, on top of Optimism, on top of ZK Sync, and Starkware, and Fuel, and all of these different projects, right? And will they end up basically copying these things that we designed? Will they design their own things? Will we have different versions of the EVM now? What will be the role of the Ethereum Foundation? Will we start becoming more of a standard? Not we, I'm not technically part of that. Will the Ethereum Foundation and friends become more like a standardization organization, right? Where we basically just kind of coordinate between rollups and making sure that the experience for users is consistent across all these layers. I think those are completely open questions right now. I think they will be very important, maybe not in the immediate future, but I think 2, 3, 4 years from now, these will be really important questions to ask. And then one last thing that I just thought was fun to maybe put on the slide as well. What does it mean for the Ethereum community? Will that also be unbundled? Will we 5 years from now still have Ethereum conferences, or will we have Starkware conferences and Optimism conferences, and maybe Solana on top of Ethereum as a rollup conferences, right? Like, is there, like, what does it mean in the future to be the Ethereum community? I don't know. Maybe we will remain as one thing, or maybe we will kind of be unbundled as well. Yeah, and with that, thanks. And if you have questions, I think I might even have, well, 1 minute, so maybe one question or something. And you want to see like the slides or something, you can find me on Twitter. And yeah, thanks. So. Right. Yeah, that's a good question. So as I was saying, like it's probably like just not enough time to do like a technical deep dive. It was only really proposed, I think, 3 months ago or something plus minus. So the idea is really just to look at the sharding that we want to do with data and realize it just doesn't make sense to have 64 different shards, but none of them actually do execution anymore. They all just provide data. Why are they on shards, right? So basically now what we are doing is we're building, well, under the hood. So if you want to have like a 30 seconds technical deep dive. So basically what we're building is actually we're building like a two-dimensional data matrix. So we have like a 256 by 256 kind of little boxes, and each of the boxes you can fill with data. And then we just basically assemble that into like a square. And then basically what we do is we basically assign individual rows and columns for different validators to sample and attest to the validity. And we also do erasure coding where we extend the rows and also the columns. And then we have like very fancy cryptography so that you can make sure that even if only a certain subset of the data remains available, you can always reconstruct all of it. So it's basically just a more efficient way of really boiling the problem down, saying like we are not bound to all the legacy plans we had. Let's actually think this thing through from first principles. What does it mean to make data available? What is the most efficient way we can do that? And that's basically this dank sharding. Yeah. So basically, for one, you can have a more efficient networking for like doing all the sampling and everything, and then also it's generally simpler. So like the kind of on the kind of validator side, it's less complex to set that all up. And then I think most importantly though, you get better security guarantees, because before that, basically you only had like within each shard, the data was kind of erasure coded and you had all these guarantees. But if a single shard failed, then the data was basically corrupted in that shard. Whereas now it's this two-dimensional. So basically you'd have to not only corrupt the row, like a row, but you also would have to corrupt every single column within that row. So basically it gives this two-dimensional security. I don't know. It's probably very confusing just saying it like this, but if you actually look at the math and cryptography behind it, I don't know. It took me a long time to even just go through the math, but it's actually pretty nice. Yeah, so I'm actually not like a networking expert specifically, but I know that people are now starting to plan out what exactly this means in terms of this whole sampling, and it's basically still a form of committees, right? And how do they find like communicate and all these kind of things? And I think some of this still uses the same principles, but I'm not the right person to ask how much of this is the same versus different. Okay, I think that's all. Thank you all so much.